First of all, let me express my gratitude to the Swallowtail and Bearded Butterfly Trust for the invitation to participate in this conference. The objective of this talk is to present the main aspects of concern about the conservation of the Apollo butterfly in Spain. I will place special emphasis on those habitats with markedly Mediterranean characteristics where the biology of the butterfly is most stressed. I will introduce the conservation programs carried out in the region of Valencia. Parnassus Apollo is a well-known butterfly from the conservationist point of view. It is the first invertebrate that received interest by the legislation, and in the 30s was already locally protected and was early included in different lists and international agreements. In Spain, is included in all those regional catalogues where the species is distributed. In the region of Valencia, where most of the experiences of conservation I'm going to talk about are being developed, it is included as a vulnerable species in the Annex 4, at the same level than relevant vertebrates of the Egyptian vulture, the otter, or the Audouin skull. The main topics I'm going to deal with in this talk are I will introduce some data on the origin and distribution of the populations in the Iberian Peninsula. I will include some briefly biological traits of the species in the Mediterranean habitats, with a special reference to major concerns for the conservation. I will talk then about our conservation experience with populations in the region of Valencia that we will call the study area. I will include some details on the monitoring of the populations and how we are going to manage the experimental recovery in the area. I will finally discuss some future directions in our research. Prognosis Apollo is mostly distributed in Central Asia. The populations in Europe are highly fragmented, and the populations, concretely in the Iberian Peninsula, represent the western limit of the distribution, but also some of the southernmost populations of the species. In the Iberian Peninsula, the Apollo butterfly is quite widespread and follows most of the main mountain ranges in the Iberian Peninsula, from the north to the southern mountains in Sierra Nevada. The study area where I'm going to concentrate my data come from the eastern part of the study area. The species is absent from Portugal and the Balearic Islands, and in 2010 was known from nearly 600 localities ranging from 700 meters in the north of Spain to 3,000 meters in altitude in the Sierra Nevada. From the conservation point of view, it is also important to consider the origin of the populations in the Iberian Peninsula. Molecular evidence points out that the Iberian populations are a consequence of two dispersal events, two independent events. The oldest will have coincided with the beginning of the Würm glaciation, approximately no more than 100,000 years ago, and would correspond to most of the population in the center and south of the peninsula. The population of the Pyrenees and probably population in general of north of Spain would correspond to a second expansion event beginning no more than 50,000 years ago, populations that would have diversified later coincided with the last glacial maximum. Apollo butterfly love open spaces with no forestry barriers where males and females may interact visually. They are active flyers and they need a frequent supply of nectar, mainly provided by thistles and other purple inflorescence that must coincide in time of space with the butterfly. And this is important for the conservation of the species. The females lay the eggs scattered on rocks and other plant debris, and not necessarily on the food plant. The eggs will develop quickly, immediately, but the larvae will remain in the chorion. And this is the state in that the larvae, the first larvae instar, will undergo a diapause, time in the autumn and winter. The eggs will hatch between December and February in our area, and they immediately need to find the food plant. The larvae may feed on a variety of crassulaceae plants, mostly of the genus Sedum. In the study area, Sedum sediforme, Sedum dasyphilum, and Sedum album are the most usual of food plants. The adequate conditions for survival of the species are only found in relatively high altitudes, and this is very common in many areas in Europe. In areas relatively close to the coast, it is difficult to reach the adequate high altitude. So those populations, as the ones we are studying, live really at the limit of altitude for survival. Two habitats are adequate in the taking into account the classification of the Nature 2000 European Union codes, the 4060 and 4090, cover the adequate characteristics for survival of the species, and they are pretty predictive on the possibilities of the species. Both habitats have in common to have poor soils and practically skeletal, where many vegetables have difficulties to progress, but stone crops and thistles benefit from this lack of competition. Of the many effects of which there is evidence of effects on the populations of Apollo, it is worth distinguishing those whose effects in the area may have been more or less local from those whose magnitude is really beyond control. Pollution, for example, by heavy metals have been in connection with industrial development has been included as one of the causes of population decline in some European areas, but industrial development in Spain was very late and has certainly never affected high altitudes. The use of pesticides, for example, is another potential cause of decline, and in some populations really may have a direct effect. However, the most common insecticide treatments in mountainous areas aimed at the pine processing area were carried out in winter, and they were rarely uh, developed in this type of areas where the pine forest is absent. The most intense treatments reported were carried out in the 70s when the species was still maintaining significant populations. The reduction has been observed much more recently, when probably these kind of treatments are not applied. We like information about natural enemies in the area that may have affected our populations. Fire is another interesting aspect. In these high altitudes, fire has always been connected with human activities. Its shepherds managed livestock grazing using fire. This effect has completely disappeared today, and it is worth asking whether its consequences have been positive or negative, or perhaps negative. Sports and tourism, mostly connected with ski facilities, must have been a problem in some areas of the butterfly's distribution in Spain, especially in the Pyrenees, but not in these more eastern areas where there is very little skiing infrastructure. The collection of specimens is another cause that appears repeatedly among the causes of the deterioration of these populations. However, we must say that the collection of specimens of this species has been prohibited for decades, and there is a clear monitoring on this aspect. Decades of ban of prohibition have not prevented the decline of populations, and so we should accept that collecting is not really a main force for the decline of populations. Uh, Wind farms are another worrying element, but unless these facilities are built exactly in the same area where a population is located, there doesn't seem to be a direct relationship between the decline of the populations and the presence of these facilities. More worrying are those effects of generalized character that may affect the biology of the species. A polo butterfly, for example, is able to survive in small populations, often with a high degree of inbreeding, and this often brings the populations closer to critical levels from which it is difficult to recover. A serious problem is the succession of the vegetation, which can endanger the nutritional plants of the species, both for the larva and for the adult. The lack of herbivores that normally stop this vegetation succession, both the or the overprotection of the territory with inadequate forestry practices can intensify this problem. And finally, global warming is no doubt a major force at this time. In recent years, an unprecedented drought has been recorded with abnormally high temperatures both in summer and winter, which are no doubt representing a problem for the growth of nutritional plants. We know that the egg phase is especially sensitive to temperature and desiccation, and that the adult phase needs thistles to prevent the dispersion of the females, which leads in consequence to inadequate laying. The nature reserve of Peñagolosa in the province of Castellón represents one of the most emblematic areas of our geography. A well-known population of Apollo was known in the area, and an evaluation was carried out in 2002. It was probably the first time an evaluation of a population was conducted in Spain. The Apollo butterfly is very adequate for capture-recapture. They are very quite large specimens. They are white, so they are easily marked. They are easily detected in flight. They survive for several days, and the sex is also very easily identified. The algorithms developed by Kochman-Jolly-Sever to evaluate populations are perfectly applied to the case of this butterfly. The evaluation of the population in Peñagolosa in 2002 was a success. The population extended the flight between 15th of June and 15th of August, so it was 2 months in flying. The total number of emergencies was estimated approximately 650 individuals. Unfortunately, there was no monitoring between 2003 and 2006. It is the year when the last butterfly was seen, and finally in 2010 it was accepted that the population had become extinct. No exact reason has been never identified about the disappearance of the species, but no doubt this extinction became an alarm about the situation of the species in the area. As a consequence of the detected decline and extinction of the population in Peñagolosa, a detailed prospection was organized by the Wildlife Department in order to detect other populations. The map of distribution was considerably improved, and we know now that butterfly is occurring in 66 UTM grids of 1 kilometer square, extending from practically 1,000 meters to nearly 2,000 meters in the area. Two methods of monitoring populations have been implemented in the area: transects and marker capture methods. Transects are a highly cost-effective approach. It allows you to evaluate the phenology of the populations. But if you want to have more accurate data on the size of the populations, then you need to implement mark recapture methods. That is the method that we prefer in wind farm areas in the north of the province of Castellón, since 2015. 6 populations have been monitored since 2020 by the method of transects. Transects consist in 500 meters that are traveled for 1 hour, counting the specimens that fly on both sides of the transect. Simple data, as for example, when the species begins to fly and when the species stops flying, provide us information about the dynamics of the populations and also about the extension of some local populations, as is happening during the recent drought in the area. Capture-recapture strategies render information of much quality. Questions like the extension and size of the populations, connectivity, metapopulations, and trends are of difficult evaluation by transects. However, capture-recapture models fill these gaps accurately. Unfortunately, they require a team dedicated exclusively to this work during the flying period. It is an expensive methodology. Access to some populations in interior areas of the province of Castellón has been facilitated by the development of wind farms. The severe drought of the last few years is affecting dramatically these populations, and this methodology allows us to compare the data with previous years not so seriously affected by the drought. When the population is reduced, not only the size is reduced, as we can see in this histogram, but also the connection between spots is also reduced. This reduces the opportunities, isolates the groups, and eventually may produce local extinctions. During capture-recapture methods, the number of butterflies visiting flowers is also annotated, and so the availability of flowers is evaluated and has ascended dramatically in the last few years. Nectar is a key factor to ensure quality of the eggs for the females, but obviously might also affect the quality of the sperm and other substances that the male transfers to the female during copulation. The availability of population evaluation protocols, transects, and population sizes encouraged the Wildlife Agency, in collaboration with our university, to undertake actions for the reintroduction of the species in the area where we knew it had become extinct in 2008. This was the Peñagolosa. The reintroduction of the species requires complex management decisions as well as the knowledge of other populations. We know that the recovery of populations in a stress area is going to be difficult. So the choice of the habitat is essential, and several locations were evaluated before deciding which might be the suitable place. Finally, an area about 1 kilometer in distance from the original locality was designated for the reintroduction. Once a plot of the reintroduction was decided, the habitat must be prepared, facilitating the development of suitable conditions for the species. The abundance of sedum, strong crops, was comparatively evaluated by using count-field lines, an interception method. Count-field lines involve counting the number of plants that are intercepted in a line as a core of 50 meters. The results were pretty promising, and we could confirm that the new location had at least a comparatively similar number of sedum on the soil. Planting of sedum and nectariferous plants is a critical element, and an effort has been made to proliferate these plants in the environment. Sedum coverage was improved by providing plants grown in the park nurseries. During the works were initiated in 2018, and still today we continue improving the presence of the plant. A varied number of tasks have been carried out to eliminate competing plants and also to improve the habitat, eliminating forestry barriers or other elements. Also incorporating elements attractive for larger viewers. A greenhouse has been built in the nature reserve, but this is a great facility to develop different experiments, both with larvae or adults. We may use it for different kinds of experiments and also to grow colonies in semi-captive conditions. With eggs obtained from a few females, we obtained a colony that was cultivated in plastic containers. The Really, the performance of the breeding is slow in general in these species, and it's quite a difficulty we still are trying to improve. In 2019 and 2020, groups of larvae were released in the habitat. In 2021, larvae were not released. The interest was to concentrate our attention if the butterflies we detected flying in 2019 and 2020 have been able to recover the population. In 2021, we effectively detected butterflies flying, but no detection was confirmed in the next years, 2022 to 2024, suggesting that a minimum critical population had not been achieved. Future directions include facing the serious drought that is hitting Spain during the last 3 years, still is on. That has prevented also us from extracting females for our breeding facilities. So we concentrate our efforts to improve habitat in those populations that still the species is available, and this means to improve the availability of flowers and also stone crops. We still ignore very basic information of how much the nectar quality affects the reproduction, but this is clearly our surmise. We still think that captive breeding strategy is a necessary tool for managing populations, especially taking into account the disappearances of some local populations. And we also need to concentrate on improving the performance of these breeding strategies. Control and humidity, temperature, and other variables seem to be very important. Depending on the financial support, the development of this semi-captive population is going to be a relevant tool to develop experiments and to know which are exactly the quality factors that affect the development and the biology of the species. I'm going to finish my talk without expressing my acknowledgement to all the people that has contributed from different aspects to this research. More than 40 people has been cooperating for years in this research from different aspects, from administrative to field work, including my students, my lab students. I would like to stress especially my gratitude to the Wildlife Agency, the renowned firm, as well as Baixeras and obviously to the authorities to the nature reserve. Thank you all for your attention, and don't hesitate to contact me for further information. Thank you very much.